Okay, this is 8th grade lesson 4.2. The objective: students will graph functions and determine if the domain is discrete or continuous. The standard is 8F1 and 2. The page numbers out of the hardcover book are pages 154 through 159, and out of the practice journal, pages 81 through 84. So yesterday we worked briefly with discrete and continuous domains. So we're going to go ahead and continue that process because I know that with the activity you don't get a whole lot of practice in understanding that. So we're going to go ahead and discuss those once again. So your domains, remember, are your X's. So a discrete domain is a set of input values that consists of only certain numbers in an interval. So for example, if we were to graph out whole numbers, that would be a discrete domain, meaning we can't include numbers that would fall between, like, for example, 1 and 2. So discrete domain is where you're going to use dots to graph out your line, and you are not going to connect them with the line because that line is telling us anything that fell between would satisfy the situation. Okay, a continuous domain, it continues between each and every single point involved in the scenario, is a set of input values that consists of all numbers in an interval. So for example, all of the numbers from 1 to 5 would be, like you could say 1.5 would satisfy a number between 1 and 5. Whereas when we did the one up above that was integers are only whole numbers, so you can't include those halves, okay? So this is just giving you a visual representation of what discrete versus continuous mean. Continuous follows the line, it continues throughout the line, and discrete means it's only those certain things. When you talk about being discrete, it's kind of being withdrawn and only keeping those things to yourself. So these would be discrete situations of graphing. We're only talking about those numbers that are plotted on. Okay, so those are just a couple visuals of discrete versus continuous. Okay, so we're going to go ahead and work some different scenarios here. So as I'm working through these, you should also be maybe practicing and understanding how to solve an equation, which you guys have worked with earlier this year. So that would just be a good practice to go through and do that, as well as graphing it out, understanding when you're going to do discrete versus continuous. So we're going to discuss that before we even start the problem. So here it says the function y equals 15.95x represents the cost in dollars of X tickets for a museum. Graph the function using a domain of 0, 1, 2, 3, and 4. So first of all, domains are your X's. So you'll notice that I've already set up my table with my 1595 in each of the boxes, and then my X's I'm using 0, 1, 2, 3, and 4 for my domains, also known as my inputs. Okay, so my numbers here are going to be 0, 1, 2, 3, and 4. We're not going to use any other ones. Those are the only ones that they asked us to use. Okay, so it's going to cost us $15.95 for each ticket. So we want to figure out if we were to buy one ticket, how much it would cost, 2 tickets, how much would it cost, and so forth, all the way through 4. So my first question is, let's determine if when we graph this, it's going to be discrete or continuous. So the question that I always ask myself, can I buy a partial of one of my X's? So can I buy a part of a ticket? No, I can't. So that means that it is going to be discrete. I can only do the exact numbers that are stated there. So I am not going to use a line. I am going to do dots. So that's another way to remember. When do I do dots? Or discrete is dots. They both start with a D. Continuous continues on the line. Okay. So we're going to go ahead and now solve for each of these. So if we substitute in 0 for X, well, 0 tickets would cost us $0. So our ordered pair is 0, 0. So I'm using these two numbers to set up my ordered pair. So over to 0, up to 0. Okay, so now my next one, if I buy one ticket, I'm going to plug that in there. So $15.95 times 1 is going to give me $15.95. So I'm going to finish setting up my graph. So for each of these, I'm just going to go by $15.95 here. Okay, so then if I did graphed that out, I'd go over to 1 and up to $15.95. If you wanted to go ahead and do like 10, 20, 30, 40, 50, that's okay too. This just makes it easier to graph it out if I do the exact amount. So $15.95 times 2 tickets is going to be $31.90. Okay, so I'm going to go over to 2 tickets and up to my second box, and I'm going to mark that as $31.90. Okay, so 3 tickets is going to cost me $47.85. So I'm taking 3 times the $15.95. Okay, so I'm going to go over to 3, and then this next box I'll mark as $47.85. Up to $47.85, put my dot. And then 4 tickets is going to cost me $63.80. So $63.80 here. And I'm going to go over to 4 and up to $63.80 and put my dot. Okay, so we already decided that this is going to be discrete, so we're not going to connect our dots. We cannot buy a part of a ticket, so therefore we can't use that line to connect and say that everything that would fall in between that. So that continuous is telling me I could connect everything. In this situation, we're not going to go through and connect them because we cannot buy a half of a ticket. Okay, so let's go ahead and try another one of these. Okay, so here's our next scenario. It says the function m equals 50 minus 9 times d represents the amount of money, m, in dollars that you have after buying d DVDs. Graph the function. Is the domain discrete or continuous? Explain. Okay, so let's break this down. So when we look at this function, what I'm getting from this is we could start with $50, and then it looks to me like every CD or DVD, is going to cost $9. So if we were to buy 1 DVD, well, to see how much money we would have left in our wallet or whatever, we would take 9 times 1 is $9. And then 50 minus 9 is going to be $41 left over, okay? So we're gonna go through and actually, we get to pick our domains for this. So before we get going, let's discuss out what could be our possible domains, or what type of domain it would be. So can we buy, because this is representing our DVDs, can we buy a partial DVD? No, we can't go out and buy a half of a DVD. So that means it's going to be a discrete. So we are just going to use dots, okay? No connecting of a line. So our inputs, well, let's go through. We could buy 0 DVDs, right? So if I put 0 in place of D, 9 times 0 is $0. 50 minus 0 is still gonna leave us with $50 left over. Okay, this is not big enough for me to write in, so I'm not gonna write it in there. Okay, so that means our ordered pair is over to 0, up to 50. Okay, so let's go through. We're going to do these and then I'll decide what numbers to use. Let's go ahead and put a 1 up in this where D is. So I've got 50, or M, equals 50 minus 9 times 1. So I could buy 1 DVD. 9 times 1 is 9. 50 minus 9 is going to give me $41. So I could have $41 left over. So 1 comma 41. Okay, so now let's substitute in a 2 here. This time we're going to buy 2 DVDs. So 9 times 2 is 18. 50 minus 18 is going to leave me with $32. Okay, so we could buy 3 DVDs. So this time we're going to substitute in a 3 there, which gives us 27. So if we take 50 minus 27, it leaves us with $23. Okay, so we'll continue. We still have more money to spend. Maybe we're going to buy 4 DVDs. Okay, so 9 times 4 gives me 36. So if we take 50 minus 36, that's going to leave us with $14. So 4 DVDs, we would have $14 left over. All right, let's go ahead and do 5. So 9 times 5 is 45. So if we buy 5, we would have 50 minus 45 is $5 left over. Can we do 6? So if we try 6, let's see. Is that reasonable if we do 6? How do we know when to stop? Well, let's think about the situation. If we were to buy 6 DVDs, that's going to cost us $54. We only have 50 to spend. So we cannot do 6, okay? So we're going to end up with the most that we can buy. We could end up with $5 left over, or we could end up with money in between. So we already decided this was going to be a discrete. We're not going to use a line because we cannot buy a part of a DVD. So this is money remaining. And it looks to me like we have to get up to 50. So let's maybe go by 5, 10, 15, 20, 25, 30, 35, 40. Let's do each box worth 10 because I don't have quite enough to go by 5. So that's $10, $20, $30, $40, $50, and we don't need to go any higher because all we have is $50. For our DVDs, we're going to do each box worth 1. Okay, and we don't need to continue past 5. So now we're going to go ahead and graph our information over to 0 up to 50, over to 1 up to 41, so just a little bit above the 40, over to 2 up to 32, over to 3, so these are done, over to 3 up to 23, over to 4 up to 14, and over to 5 up to 5, we are done. Okay, we are not going to connect our dots because we cannot buy a part of a DVD. So we're going to leave it as just dots. Okay, so there's 2 scenarios of working with discrete domains. Okay, so discrete domains mean for the domain or our x's, we cannot do a partial. Okay, we have to just stick with dots, meaning it has to fall on those locations. Okay, so here we have a 20-gallon bathtub that's draining at a rate of 2.5 gallons per minute. The number of G gallons remaining is a function of the number of M minutes. Graph the function. Is the domain discrete or continuous? So our domain are our X values. So we're going to drop 2.5 gallons per minute. Can we do a partial minute? So our X's are our minutes. Can we check at a partial minute to see if how many gallons are left over? Yes, we can. So because we said yes to that, then that means that this is going to be a continuous domain. We're going to use a line through it. Okay, so continuous, we're going to connect. Okay, so we're going to go ahead and do our scenarios. Okay, so this is going to be gallons remaining. Okay, so we are going to start out with 0 minutes. So at 0 minutes, our equation, it's going to drop. So our y is going to equal 2.5 at a rate, so it's draining. So it's negative 2.5 per minute. So we're going to do plus 20 in the back. And the reason I'm doing plus 20 is we start out with 20 gallons. So we're dropping negative 2.5 gallons per minute, and we're starting out with 20 gallons. That's going to tell us what's remaining. Okay, so we're going to go ahead and substitute in a 0 where this is. Negative. And I'm writing this really big so it's easier for me to erase. Okay, so if we put a 0 in there, negative 2.5 times 0 is 0 plus 20. Well, we have 20 gallons remaining. Okay, so our ordered pair is over to 0 up to 20. Okay, so let's go ahead and do the next one. This time we're going to do after 1 minute. Okay, so negative 2.5 times 1 minute is going to be negative 2.5 plus 20. Okay, if you're not comfortable with integers, then use your calculator. So if I take 20 minus 2.5 gallons, that's going to give me 17.5 gallons remaining. Okay, so now we're going to go ahead and do 2 minutes. Okay, negative 2.5 times 2 is 5, so negative 5 plus 20 is going to give us 15. So there's going to be 15 gallons left. Okay, at 3 minutes. Okay, negative 2.5 times 3 is negative 7.5 plus 20 gives me 12.5 gallons remaining. Now we'll do 4 minutes. So negative 2.5 times 4 is going to give me 10. So negative 10 plus 20 is going to give me 10. Okay, so you can see the pattern. You can see that right now at the halfway point, that 20 gallons, it would take 4 minutes to get half of it empty, right? Because we originally had 20 gallons and now we have 10 at halfway, which is 4 minutes. So we could now guesstimate how long it's going to take. Well, it's going to take us all the way out to 20 minutes to get this, or not 20, 8 minutes to drop the 20 gallons. Okay. Now, the reason I'm doing that is just for time's sake, and we already figured out that this is continuous, so we don't need every single one in between. We are going to graph our beginning point and our ending point when we have nothing left over. Okay, so we're going to go ahead and how do we know that we're done? Because if we were to continue and go into 9, well, negative 2.5 times 9 is going to give us negative 22.5. We can't have negative gallons. Okay, so that's how we already know that it's empty. And I'm thinking about the scenario as I'm going. Okay, so I'm going to go ahead and set up my graph. So my minutes, well, we went anywhere from 0 to 8. So we'll do 0, 1, 2, 3, 4, 5, 6, 7, and 8. And for our gallons, well, we started out with 0 and we had to go through 20. So maybe we'll go by 5s. 5, 10, 15, and 20. And we are just going to graph our first and our last ones and connect the dots. Okay, if you want to graph every single one in between, you can, but when it's continuous, you do not have to do that because your line is going to graph that for you. So at 0 minutes, we would have 20 gallons remaining in our bathtub. And at 8 minutes, so that's this one here, we're going to have, that shouldn't be 20, this should have been 0, sorry. No wonder you guys were probably confused. That should have been a 0. At 8 minutes, we're going to have 0 gallons left in our bathtub. So now I'm just going to go ahead and connect that with a line. Okay, and the reason we're doing a line is because we could have anything in between. It does not have to just be at 1 minute, at 2 minutes. We could check at 5.5 minutes, and we should be able to use this graph to see approximately at 5.5 minutes. It looks to me like it would fall somewhere between 5 and 10 gallons, maybe about 6 or 7 gallons that would be in there. And we can use the graph to actually do that. Okay, so a continuous means that you can include anything that would fall in between your domains that you're using. Okay, so let's go ahead and do another one. So here we have a cereal bar, contains 130 calories. The number of C calories consumed is a function of the number B of bars eaten. Graph the function. Is the domain of the graph discrete or continuous? So let's discuss out. Could we eat a part of a bar, like a cereal bar, a granola bar, or whatever? Could we eat part of one, like just like half of one? Yes. So since we could eat a partial bar, then that means that this is a continuous domain, meaning we could eat 1 bar, we could eat 1.5 bars, we could eat 3.5 bars. Okay, it does not just have to be 1 bar. We could eat a partial of a bar, which means that this is going to be a continuous domain, okay? So it's 130 calories per bar. So in order for us to find out our total number of calories, we're going to do our calories equals 130 per bar. Okay, that's where we would normally have our X's. So I'll just put B here. So this is going to be our bars, cereal bars, and this is going to be our calories. And I'm just using C and B because it represents, instead of X and Y, I'm understanding that C is the number of calories and B is the number of bars. Okay, so we're going to go ahead and start out with 0. So if I have 0 bars, well, that's going to be 0 calories. Okay. What if I ate 1 bar, 1 cereal bar? If I put 1 in place of B, so if I put a 1 in place of B, well, that would be 130 calories. So 1 bar is 130 calories. What if we ate 2 bars? So this time I'll put a 2 in here. Okay, 130 times 2 is 260 calories. So 2 bars would be 260 calories. How about 3 bars? So now we'll put a 3 here. Okay, 130 times 3 would be 390 bars. Okay, you get the idea. We could continue in this manner infinitely. Okay, nobody told us that there was only a certain amount of calories that we could consume. We were just trying to figure out how many calories we would consume on any given amount of cereal bars that we ate. So we're going to go ahead and we're going to plot out these first, at least 3. You should do at least 3. Don't do less than 3 because if you're off on one of your dots, it's going to throw your entire graph off. So it looks to me like if I do my calories, I'm just going to do them every line worth 130. It's going to make it easy to graph. So this would be 260. This would be 390. And granted, you could do each one worth 100. I'm just trying to make it easy for you to graph because that's what I want you to be able to focus on is the discrete and continuous and not stress about if you're getting your dots in the right spot. Okay, so then our bars, well, 0, 1, 2, 3, 4, and so forth. Okay, so we're going to graph the first 3. We could eat 0 bars, which would consume 0 calories. So that one's graphed. We could eat 1 bar over to 1 and consume 130 calories. We could eat 2 cereal bars, so over to 2, which would be 260 calories. We could eat 3 cereal bars, which would be 390 calories. And we could continue in this fashion. So when we do this, this would be continuous. There is no end point on this one, so we're thinking about the scenario given to us, which means we're going to go ahead. We could eat a partial bar, which means if I only ate a half of a bar, yes, my calories would fall between 0 and 130, okay? But we're going to go ahead and connect this all the way up, and we're going to continue it out and put an arrow on the end, which means it continues forever with an unending limit, okay? So here there wasn't a limit of how many calories we could consume. Okay, so that's doing another one that's working with continuous. So main things out of this lesson. The main things out of this lesson are for your continuous, you use a line to decide if it's continuous or discrete. Continuous means you could have a part of your domain, a part of your X's, a part of your input. Okay, you could do a partial of whatever the scenario is. So like here it was cereal bars. Okay, for it to be discrete, so if we jump back, okay, discrete domains, you can only have exactly the number stated. You cannot buy a part of something. So in this situation, we were talking about DVDs. We could not buy a half of a DVD. Okay, so discrete, you're going to use dots, discrete dots, continuous lines. Okay, so that's pretty much it for this lesson. Good luck. Keep plugging away and just remember that if you can't buy a partial of something, then that would be a discrete. If you could do partial of whatever is stated, then that would be a continuous.